Dear children, welcome to the second module of our chapter Work and Energy. I hope you all are fine and doing good. Today we are going to discuss about energy. And in this chapter, mainly we are discussing about two types of energy, that is kinetic energy and potential energy. So let's see these terms in detail. Children, energy is one of the commonly used words. Very often we come across the statements like the person is full of energy or the patient is feeling restless and has no energy, etc. Have you ever seen energy? The answer is no. But life is impossible without energy. And in your previous class itself, you learned the sun is the biggest natural source of energy to us. How can we define this term? Energy is defined as the ability to do work. That is, an object having a capacity to do work is said to possess energy. The object which does the work loses energy, and the object on which the work is done gains energy. An object that possesses energy can exert a force on another object. When this happens, energy is transferred from the former to the latter. The second object may move as it receives energy and therefore do some work. Thus, the first object had the capacity to do work. This implies that any object that possesses energy can do work. The SI unit of energy is same as that of work, that is joule. In nature, we find energy in various forms. For example, chemical energy, sound energy, light energy, electrical energy, heat energy, magnetic energy, nuclear energy, mechanical energy, etc. And in this chapter, we are mainly discussing about two types of mechanical energy, that is kinetic energy and potential energy. So first we will be discussing about kinetic energy. Children, we can observe many energy transformations around us. In the case of a lighted torch, chemical energy is converted to light energy. When you are cycling, from where do you get this energy for your activity? You are getting the energy from the food which you are eating. So there the chemical energy is converted to mechanical energy. When a fan is working, electrical energy is converted to mechanical energy. When a bulb is lighted with the help of electricity, electrical energy is transferred to light and heat. So these are examples of energy transformations. In all these cases, we can see that energy is converted from one form to another. Children, we know that a moving hammer can do work on a nail it strikes. A moving cricket ball can do work on stationary wicket it hits. Therefore, a moving body is capable of doing work and hence possesses energy. The energy possessed by a body by virtue of its motion is called kinetic energy. That is, it is the energy possessed by a moving object. A falling coconut, a speeding car, a rolling stone, a flying aircraft, flowing water, blowing wind, a running athlete, etc. possess kinetic energy. In short, kinetic energy is the energy possessed by an object due to its motion. The kinetic energy of an object increases with its speed. That is, an object which is moving faster can do more work than an identical object moving relatively slow. Next, we will see the expression for kinetic energy. So, to derive the expression for kinetic energy, first we have to consider an object of mass m moving with a uniform velocity u, and let a constant force F acts on it, which displaces the object through a distance s in the direction of force. So you can see here object which is having the mass m, and when we exert a force F on that object, it is displacing a distance s. Initially, this object was moving with a velocity u, that is the initial velocity, and when we apply the force, its velocity changing to the final velocity, that is v. Therefore, the work done in this case is equal to, that is work done W is equal to, we learned the equation for work done. Work done is the product of force and displacement. So here we can write the work done W is equal to F into S, that is force into displacement. This equation we considered as equation number 1. So children, we can see here a work is done. Because of that work done, the velocity of this object is changing from u to v. Therefore, an acceleration a is produced. The relation connecting the initial velocity u, final velocity v, acceleration a, and displacement s. You have already learned this equation in your first chapter. This is one of the equation among equations of motion, that is v square minus u square is equal to 2as. From this equation, we are writing equation for s, that is for displacement. See, this we are writing to substitute in our equation number 1. That means our equation number 1 is the work done equation. Work is equal to force into displacement. So, for force and displacement, we are giving substitutions. So, for s, we are writing here as the equation as s is equal to v square minus u square divided by 2a. This equation we considered as equation number 2. Children, now we will write the equation for force. In your second chapter, from second law of motion, you have seen that force is equal to mass into acceleration, that is F is equal to ma. This is our third equation. Now we are substituting equation number 2 and 3 in equation number 1. See, our equation 1 is W is equal to F into S. Work done is equal to force into displacement. Now we are giving substitution for force and displacement. So F we are replacing with the term ma, and S from equation number 2 we are replacing with the term v square minus u square divided by 2a. You can see the acceleration term will be cancelled, and final equation we are getting is W is equal to half m v square minus u square. So this is the work done you have done in this object. So this work done is equal to the change in the kinetic energy of this object. If the object is starting from stationary position, see in this case we told the object was initially moving with a uniform velocity u. But if the object was at rest, then we can tell the initial velocity term u will be 0. Therefore, the equation will be changing as W is equal to half m v square because u is 0. So, equation 4 will change it as W is equal to half m v square. So, children, we can express the kinetic energy possessed by an object of mass m moving with a uniform velocity v as Ek. Ek represents kinetic energy equal to half mv square. Therefore, the kinetic energy of a body is directly proportional to mass of the body, and it is also proportional to square of the velocity of the body. You can see in the equation consists of mainly two terms. One is m and the second is v square. So m represents mass and v square is square of the velocity. So the equation for kinetic energy is Ek is equal to half mv square for an object of mass m moving with a velocity v. But if the initial velocity term is there, then you have to consider the equation Ek is equal to half mv square minus u square. So I hope it is clear. Watch the next video. In this video, we can see the two types of mechanical energy, that is kinetic energy and potential energy. We will discuss in our next module about potential energy in detail. Yes!